Alright, so if you remember with our decomposition, our goal was, rather than Algebra 1, where you were given two fractions like this and you were asked to add them together, okay, now we have what they equal and you're to break them apart into two separate fractions, okay? Now we said yesterday our first step is going to be to factor the denominator. And the reason for that is because when you factor the denominator, that shows us that there are two separate factors that went into making that one denominator. So we're going to need two separate fractions in order as our partial fractions. Okay? So you'll see here we wrote our original fraction x plus 7 over x squared minus x minus 6 equals something over x minus 3 plus something over x plus 2. Okay? Now, what we're going to end up doing is multiplying both sides of the equations by the common denominator. And because of the way we did this, the common denominator is going to be the original denominator. Okay? And it will always work out that way. So we're going to multiply this by x squared minus x minus 6. I'm going to multiply this side by the same thing, but I'm actually going to use its factored form. X minus 3 times x plus 2. And I'm going to multiply this by x minus 3 times x plus 2. And I'm doing this because we have to distribute to both parts. Alright, so now you'll notice what happens is our denominator cancels out and we're left with x plus 7. Here, the denominator cancels that factor, but I still have an a times x plus 2, plus, here the x plus 2 cancels that factor out, and we have b times x minus 3. Okay? Yes?
How would a question for decomposition look like? How would it be in the test?
Just like this. Write the partial fraction decomposition of that.
Alright, so they wouldn't give you the...
No, you would not be given this part.
Okay.
You would have to factor this to determine that you need to write two separate fractions there. Okay? Alright, so now let's see what we get. We have x plus 7 equals ax plus 2 times a. Alright? That's our x. Notice all those terms have x's. And then a times 2, b times x is bx. And b times the minus 3 is a minus 3b. I did this intentionally, although I should, hang on, I messed up my colors. Okay.
Yeah, you're not going to see
yeah. Someone.
We all know it's 100% Spencer already playing.
Oh, I thought it was your headphones, Julio.
Yeah.
I was looking at you like, what are you listening to?
That's alright.
That?
It's for a class.
Oh.
They were doing an experiment. That's okay.
Oh, man.
Alright, anyways, you see here the x portions are all in blue. Alright? And you'll notice over here, we only had one x. That 1 has to come from whatever a plus b is. Okay? So there's one of our equations in our system. The real number, 7, has to come from the other two real number parts. Alright? The 2a and the minus 3b. Okay? Now we have a system. You guys know how to solve 2 by 2 systems. Alright? You can either do it by substitution. There's an example over there. You can do it by adding multiples, okay? For example, on this one, I would probably add multiples. Or elimination. I would multiply this whole equation by 3, so then I would have 3 plus 7 is 10, equal to 5a. Now I know a is 2, which means b is -1. Okay? So don't forget though on these to write your final answer. Okay? The whole goal of this was to then say x plus 7 over x squared minus x minus 6 equals 2 over x minus 3 plus a -1, or you could just say minus 1 over x plus 2. Okay? And that would be your final answer. That's the partial fraction decomposition of our ratio there. Okay? So, not too bad.
Hold on. Okay.
Now, one case where there's one extra thing you need to remember is if, when you factor, you end up with some repeated factors. Alright, so for example, our denominator here. You can pull an x out, right? X times x squared plus 2x plus 1. And then what does that factor into? X plus 1 squared. So x times x plus 1 squared. Now, and this is just part of the method that you're going to have to memorize, okay? When you get a repeated factor, something squared like this, when you write your partial fractions, you're going to obviously account for the x, so you're going to have a over x, but then you're going to have two other fractions in this case. One is going to just be the x plus 1, the other one's going to be the x plus 1 squared, okay? If this were x plus 1 cubed, we would have another one on the end, d over x plus 1 cubed.
Why?
Right?
3.
That's just part of the method. That this is just a rule that you've got to memorize at
If you
this
have a
point.
square, then you add you have a separate fraction.
If you have a square, then you need to have it to the first power and it to the second power as two separate partial fractions. Whatever the power is, if it's repeated, you just start with it to the first power and have one for every power up to however many you have. Okay, so if it's to the fifth power, you're going to have a whole lot of work to do. Because you'd have x plus 1, x plus 1 squared, x plus 1 cubed, x plus 1 to the fourth, x plus 1 to the fifth. Alright?
Well, you won't do that, right?
I don't know. So,
Yeah, you do.
alright. So, here's the basic idea that we're using, okay? We know we have three partial fractions in this case. So, we're going to have a system of three equations with those three unknowns, a, b, and c. Okay? That we're going to have to deal with. Yeah, Alex?
For the one that we're about to do, the x, parentheses x plus 1 squared, if there was no x before the x plus 1 squared, how different would it be?
It would just be that.
Okay.
So, yeah, we've got our common denominator, x times x plus 1 squared. Okay? That's our common denominator. And we're going to go ahead and multiply that on both sides. Now we need to make sure we distribute it to all three parts here. Okay? So we're going to multiply that. We're going to multiply that one. And we'll multiply that one as well. Okay? Alright, so we multiply all three parts on the right by the x times x plus 1 squared. We multiply this on the right, and those are the same, so that's canceled out. just like we had before, and we are left with a 5x squared plus a 20x plus 6, and that's going to equal, here we go, alright, this x cancels out the x, so we have an a times x plus 1 squared. This x plus 1 cancels out one of those two, so we have a plus b times x plus 1. This x plus 1 squared cancels out the x plus 1 squared, so we have a plus cx. Okay, so we're almost ready to write our system of equations. Notice what we're trying to get here again is we're trying to get an x squared, we're trying to get an x, and we're trying to identify the constants. Okay?
Why do we not like times x plus 1 and x?
We will.
I mean, on the right part,
Mm-hmm. Yeah, like here,
so why do we not times x plus 1 squared? Why, where's,
we're going to. This right here we're going to FOIL, x squared plus 2x plus 1, but we have to distribute the a. So a x squared plus 2ax plus a.
what I mean is like, you cancel out of x, right?
Oh, yeah, cancel out the x here.
But you have x plus 1 squared and you have one more x plus 1.
He canceled out the square.
Here, I canceled out just this, so I had a times this part
Oh, I
left.
see.
This, I canceled out one of these, 2, and I still had an x and an x plus 1.
Back to the other side.
Okay? No, don't factor the other side. Because here's what's going to happen. We're simplifying the right-hand side. We now have a plus bx squared plus bx plus cx. Alright? So now, our x squared terms are the ax squared and the bx squared. That means, watch this, the 5 has to be a plus b. Okay? The 5, because those are all the x squared terms. So whatever a plus b is has to come up to 5. Then we have the x terms. 2ax, bx, and cx.
2a plus b plus c. 20.
Yeah. 2a plus b plus c equals 20. Alright? And
a equals 6.
the constant a, that's the only one, a equals 6, which really makes this a very easy system to solve.
The ones in the homework are similar to that.
Yeah, they were nice to you.
Yeah.
So,
Or ones.
so here, a is 6, which means b has to equal
Negative 1. And C is negative 1.
negative 1. And then, if a is 6 and b is negative 1, whoops,
C is 3.
I have 12 minus 1, that's 11.
9.
So c has to equal 9. Okay? So, our final answer is,
6 over x.
yep, 6 over x
Minus 1 over x
minus 1 over x plus 1,
plus 9 over x plus 1 squared.
good, plus 9 over x plus 1 squared. Okay, and that's what the original fraction, 5x squared plus 20x plus 6, over x cubed plus 2x squared plus x equals. Don't forget to write your final answer, please. Okay?
So the answer would technically be 6x squared.
The answer would be 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared.
Could you, let's say the 3 equations in the system were complicated, could you use the row echelon form?
Mm-hmm.
Yeah, I can
That would do.
Yeah, once you have the system, whatever it takes to solve it, do it.
I don't understand how you got the 6 equals 8
Here we were looking at the squared parts to get this equation, because we had a 5x squared. We were looking at the parts that just had x's, that 2ax, the bx, and the cx, that 2a, the b, and the c had to give us the 20. But then the constant part, if you look, the only thing that doesn't have an x is that a right there. So,
Are we gonna get,
Could you simplify that further by square rooting the last term in the answer?
no, because it's not, it's just an expression here. It's not like an equation where you can just square root both sides or
So
something.
just like the-
You would just leave it. You're right, that is a perfect square, but
are we gonna get, like these ones or like the one we did before on the test?
well, like this or this,
Yeah.
either one.
Either one.
Yeah, you could do either one.
It's gonna be
So-
this long one.
Yeah, it's gotta be a long test.
Long matrices and these.
So, all right. So that's it for the partial fraction.